In the field of natural language processing, retrieval-augmented language models, or RALMs, have become essential for enhancing the capabilities of large language models. These systems work by fetching relevant documents from an external database and using them to inform responses to user queries. This process, known as Retrieval-Augmented Generation, or RAG, helps bridge gaps in a model's internal knowledge without needing to retrain the entire system. For instance, when you ask a question about history or science, RAG pulls in supporting documents to provide accurate, up-to-date answers. However, this approach isn't without its challenges. Retrieved documents often contain a mix of useful information and noise, things like irrelevant details, redundant content, or even factual errors that can mislead the model. In practice, when these documents are fed into an abstractive compressor, a smaller language model designed to summarize and condense the information, the compressor might overlook key facts or amplify inaccuracies. This is especially problematic in long contexts, where the model's attention can get dispersed across too much text, leading to incomplete or incorrect summaries. To tackle this, researchers from Korea University, including Singin Kim, Gunho Yoon, and Seong-Won Lee as the corresponding author, developed a new method called ACoRN, which stands for Abstractive Compression Robust against noise. ACoRN is specifically designed to make abstractive compression more reliable in real-world scenarios where retrieval noise is common. The core idea is to refine how we handle and summarize retrieved documents by introducing two innovative training steps. First, let's break down the types of noise that ACoRN addresses. There are two main categories: irrelevant information, which doesn't help answer the query, and misleading content, which might be factually wrong but still scores high in relevance. For example, imagine querying about the Great Lakes and their connection to the ocean. You might get documents that correctly mention the St. Lawrence River but also include unrelated details about the lake's formation or geography, potentially confusing the compressor. To build robustness against this noise, the first training step in ACoRN involves offline data augmentation. This means artificially introducing various types of noise into the training dataset to simulate real-world retrieval errors. By doing so, the compressor learns to identify and filter out irrelevant or misleading parts more effectively. Specifically, the researchers augment the data with two distinct noise types: one where documents have extraneous information, and another where facts are subtly altered to test the model's ability to detect inaccuracies. This step trains the model to prioritize query-relevant content, ensuring that even in noisy environments, the summary remains focused and accurate. The second training step addresses another limitation: the compressor's inability to fully integrate information from multiple documents and its tendency toward positional bias. Positional bias occurs when the model gives more weight to information that appears earlier in the input, potentially ignoring crucial details buried later. To counter this, ACoRN incorporates fine-tuning techniques that encourage the compressor to generate summaries centered around key information directly supporting the correct answer. This is achieved by modifying the training process to emphasize evidence-based summarization. For instance, during fine-tuning, the model is trained on examples where it must extract and highlight core facts, like the exact path of the Great Lakes to the ocean, while downplaying less relevant details. In their experiments, the researchers applied ACoRN to a T5 large model, which is a popular language model known for its efficiency in summarization tasks. They evaluated it on datasets that included a high volume of noisy documents, measuring performance using metrics like exact match, M, and F1 scores. M checks if the generated summary exactly matches the ground truth answer, while F1 assesses the precision and recall of the key phrases. The results were promising. T5 large trained with ACoRN showed significant improvements in both M and F1 scores compared to baseline models. Importantly, it preserved the answer strings, meaning the core evidence needed for accurate responses was maintained intact. To illustrate this with a real example from the paper, consider the query: where do the Great Lakes meet the ocean? In the retrieved documents, there might be multiple references to the St. Lawrence River as the connection point, but also distracting content about water flows or historical formation. A standard compressor might produce vague or incorrect summaries, like saying the lakes meet the ocean at Chicago, which is wrong, or simply stating there's no information. But with ACoRN, the compressor generates a more precise summary, The Great Lakes meet the Atlantic Ocean through the St. Lawrence River. This demonstrates how ACoRN reduces errors by focusing on verified key information. What makes ACoRN particularly valuable is its performance on datasets with high levels of accuracy, reducing documents. In real-world applications, such as chatbots, search engines, or educational tools, users often deal with imperfect retrieval systems. By enhancing noise robustness, ACoRN ensures that the final output is not only concise but also reliable, which is crucial for maintaining user trust. The researchers supported this work through grants from the Institute of Information and Communications Technology Planning and Evaluation in Korea, highlighting its relevance to advancing AI in practical settings. Overall, ACoRN represents a step forward in making retrieval-augmented systems more efficient and trustworthy. By categorizing documents in a fine-grained way and using targeted training, it minimizes the impact of retrieval noise, paving the way for better integration of external knowledge and language models. This approach could extend to other areas, like medical question answering or legal document analysis, where accuracy is paramount and noise is inevitable.